Greetings and welcome to my new calculus channel. So today I'm going to be demonstrating to you. Well, first of all, I'm going to be looking at other videos as we have here and um, seeing what they return when I ask what is pi. Is it a number? So no, none of these videos here actually tell you exactly what pi is. They tell you how you can estimate it, and they think it's a number and they call it an irrational number. But to say irrational number is an oxymoron. So why is irrational number an oxymoron? Okay, because a number implies rationality, and rationality implies number. So pi is a name that is given to a constant. In other words, a rational number. Yes. Don't argue with me. I do know better than anyone else. So this constant is a rational number. Okay. It's not an irrational number because there is no such thing as an irrational number. Okay. To be a number means to be rational. So um, pi is realized from a failed measure of this ratio. So you can take any circle, a small one, a bigger one, and even a bigger one, and then try to measure the circumference using the diameter. Okay. In other words, what you're doing is you're abstracting the measure. You're saying, you know what? I don't care about the length of the unit. And this is where algebra comes in. Algebra doesn't care about the type or the size of the abstract unit. Okay. It doesn't care about the type or the size of the abstract unit. So all the theory of fractions, etc., the operations of arithmetic and what have you are laid out in the earlier books of the elements, such as book 5, which is the most important book. But in book 7 you get this really uh, exotic definition that a number is that by virtue of which all things are called one. And what it's really saying is that a number is what we understand by using the abstract unit as a measure. In other words, we don't care about the type or the size. So we can say, all right, well, if you've got a little man, we've got a square and a circle, or an apple, whatever. Now here we don't care about the type, do we? We just say 1, 2, 3. So 1, 2, 3. And we've done a measure. We're calling these by the abstract unit. Okay. In other words, we're saying that all we care about is a measure using the abstract unit. So pi is not a number, but let's listen to what this young chap says. Okay. I did paste a comment. I don't know how long it's going to last because I'm not very popular. But let's listen very quickly to what he says. So that means in the current time or the current age that we live in, we've managed to calculate the value of pi. But few really know that Archimedes was the first, through the use of polygons, to okay, who managed to give a scientifically correct measure of pi. Well, actually, that's not quite true. That's not true at all. No one has ever measured pi. Okay, and no one can measure pi because as I said, pi has no not pi. No one can measure this ratio, the ratio of circumference to diameter. Okay, you cannot measure this ratio. That's why it's called uh, an incommensurable ratio, right? And here's a little interesting background. In modern Greek, they call rational numbers ritus or rita arithmi. Okay, riti arithmi. Now, ritos by itself means something that can be called. Okay, and aritos means something that cannot be called, or in other words, ineffable. So rito is affable, and aritos ineffable. And why is ritos affable? Because you can actually describe using quotientness the relationship these magnitudes in the ratio have to each other. Now, in the case of pi, they do not have a relationship when we try to measure the circumference using the diameter, okay? We can only approximate it to get this constant. So in reality, there's really no magnitude that can be called pi. It's an abstract constant, an abstract constant that has no exact measure. It's definitely not a number, and the best thing to do is to call it a symbol for a constant, not a number. And the same thing applies to square root 2 and all the other so-called irrational numbers. But there isn't really such a thing as an irrational number. It's a garbage concept, and of course, no one has ever produced a valid construction of irrational number. Not that idiot Dedekind or Eudoxus or anybody else. Their theories are just a bunch of crap. So, to get all the information on this, I give you free of charge the best ever book written on numbers, the ultimate book of numbers, okay? This is in the top 2%, and I am in the top 0.1% of those read. So I'm giving this to you, the ultimate book of numbers, free of charge. It's not always going to be free, okay? So I deal with everything, the concept of number, its definition, and I give you a proper definition of number for all numbers, for all actual numbers, okay? And I expose the ignorance of mainstream mathematics academics who claim that there's such a thing as a real number and an irrational number. So really, that's pretty much it. I don't really have anything else I want to say here. If you're not already a subscriber, become one. Follow me on academia. I'll place a link where you can buy me a coffee or a meal if you feel generous. And that's pretty much it. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.